Hi, welcome to this course on C programming language, and let's get started. Basics of C language and flow control. The style we will follow is to first list down the topics in the module that we are going to cover one by one, then go cover them. For instance, we'll start with our first C program, and then we'll get on with the first C program. Dennis Ritchie is the inventor of C language. In a book he co-authored, they start with, the only way to learn a new programming language is by writing programs in it. So we'll follow that approach, and by writing programs and actually running them on a development lab setup, we get even better knowledge of how we write programs. And that way, theory meets practice, and we'll be able to learn better, okay? On the right, in the box shown here, these are the first ever C program we are going to write now. And on the left are the instructions on how to compile. Let's dissect these and understand what are these. Hello.c is of course the name of the program file. Okay. The first directive #include stdio.h says, I want to use some functions, and in order to use that functions, please give me a library containing those functions. So stdio.h is the name of a header file that supplies standard IO library. So we want to include that so that we can use this function printf here. This is a main program we want to run, and this is where we want the program execution to begin. Printf is our library function that we want to use, in which we want to print something. On the left-hand side is how you execute the program. So you compile the program using a tool called CC. CC stands for C compiler. That itself is again a program, just like this program you have written. It's a more sophisticated program, okay? So use one program to compile another program. So you compile hello.c and you get an executable. In C, the default name given to a program that's compiled is a.out. So it's the name of the compiled program. Just run that. And when you run that, and you run it by typing it the name on a command prompt. Dollar is a command prompt on a computer. So you go and type in a.out and you expect to see hello world, the output, okay? So let's actually go and do it. So in order to do that, we're going to use a cloud lab environment, okay? Edureka has set up a cloud lab to be able to use the capability to execute programs and experiment and do development, okay? So let me give my login ID here, password. All right, and then I'll sign in. When I sign in, the Cloud Labs environment tells us what do we have in our lab. I have set up a Ubuntu server. So let me go and view the lab. I go view the lab. It gives details about this server and how long I have used and so on. We quickly want to go on web desktop, which takes us to our Ubuntu server, which is a Linux machine. See, I've created a terminal. So let's go and create a file. VI is an editor, visual editor. So I'm using that in order to create our hello.c. So what do I create here? Let's cut and paste from what I showed you. We want to use our program here, right? So let me copy this, come over here, paste it, and then let me say compile hello.c, right? So we expect to see an output called a.out. It gave a little warning, but then it has compiled. We'll get into what are these warnings for. That's not necessary at this time. So if you list the files, you see you have a a.out. So let's run a.out. As you know, in our instructions, you write the program in a file, you compile, and then you get an a.out, the name of the executable, which you can run. So I'm running them. If I run this, I got hello world, which is what we printed. So this is our first ever C program. Okay. Now let's go back and then look at the C program. So guys, this is the method we are going to adopt. We're going to go through the slides quickly, show you the actual program details, come to these cloud labs, actually run those programs. And I would like to do more hands-on than talking or presenting just the slides. That way you get to see exactly what's done. And then once we understand all this, we go back and summarize what have we learned. That would be the approach I'll be taking for all the modules. All right, let's go back to our modules and again ask ourselves, did we understand what we did? So we ran this program, we compiled, executed it, got the output. And in doing so, we have used various capabilities in C. Our interest now is to understand all the capabilities in C. So in this module, since it's the essentials of C, I will summarize the various things we have learned now. Okay? In our first program, main is a special function we said, which is required to execute any C program. So every program you write will have to have this main function in order to start execution of the program. This is a practice in C. So the compiler, when you compile the program and you run it, the runtime loaders which run and execute the program, they execute and from the main function that you have defined. So it's needed in order to get the program running. Okay, that's the first point. The second point, every function, in our case, main itself is a function. The other function we used was printf, right? So they're all passed a list of values called arguments. In our case, main did not have any arguments, and printf was applied. The character string hello world itself as an argument. You see, a sequence of characters in double quotes, that's called a character string in C, or a string constant. That's what we used. And if you noticed, we had used a \n in the string. The \n is a notation in C for new line character. What does new line character do? It advances the output to the left margin of the next line. I'll show you what happens if you don't use \. That way you get a feel of why \n is needed. If you don't have a new line character, it means it will not advance the output to the left margin on the next line. So let's look at that. Suppose I go back to where we were. So this was our terminal. Open the file, hello.c, modify it, take this \n out. Now if I say cc hello.c, it'll compile, and then I'll say a.out. You see here, hello world, and without any new line, our prompt has come back. So there is no new line character printed. The output is almost sandwiched with the prompt here. So if you want them to neatly appear one line after another, we have to put back. So then let's put back and see what happens. Vi hello.c, the \n, compile again, and run it. Now you see it neatly comes in the next line, this new line character. So this is our first program.
Let's get back to writing more programs to understand C better. As you are aware, we wrote our first program, hello.c. We had a main function and a printf function. The printf function had an argument, which was a string literal, isn't it, or a string constant. The main program did not have any arguments, 0 arguments, isn't it? Now let's look at what does printf do? Well, that is a very complex program. When we want to use it, we don't have to necessarily know how exactly it's implemented, isn't it? As long as we know what it does, it's enough. We don't have to know how exactly has it implemented. What all does it use in order to implement it? So a function, in a nutshell, provides us a capability to expose something useful it can do, which we can use without knowing how exactly has it been implemented. That's the power of function, to abstract things and to be able to manage everything without having to know the internal details. So let me just give you a brief overview of that, and then we can get to do a lot more functions. So what does a function do? A function does some useful work or computation that can be used for one or more programs, right? When implemented well, a function beautifully encapsulates what needs to be done, and the caller does not know how it needs to be done. The function enables us to do stepwise construction of programs because it allows us to now break up a problem into sub-problems And for each subproblem, we could define a function. We can compose the program as a set of functions, which may in turn call more functions, isn't it? By doing so, we can then compose them together and then have a program that solves our problem. It enables us to modularize and organize our whole solution or code in order to solve a problem. What is modularization? Well, a good example is the way the knowledge is organized in this world. That's a very good example of modularization. We have physics to explain the details of the physical world, biology for life and life processes, chemistry to understand chemical compositions, geography is for understanding the earth, so on, right? That's a modular argument, right? You break up the whole knowledge into manageable portions, then you can go deep into. The same thing is used in C. What is the format of a function? We already have seen. Function has a function name. In our case, main and printf were two functions we used. It has a return type. Printf did not have any return, so it was a void. There was nothing. The main program also has a return type. We'll go into that. It can have one or more arguments or none as well, isn't it? Then there are a set of program declarations to say what are we going to use in order to do some useful computation. Then the computation itself has a set of program statements, and usually all functions will have a return value. Let's go ahead now and try to write some functions, use some functions, and understand the power of functions, okay? So let's go back to our lab, the cloud lab. Let's write a program to understand how we can make use of the power of functions, okay? So let's call this power.c, okay? Any program has a main, and we want to write a program that computes the power of a number, a base, to which you raise to the power the exponent. That's the function we want to call. So what does this function do? Given any base number, it computes power of that to an exponent, all right? And we do this by calling a function power that does it, okay? Now we haven't written this POW function, right? So there is an implementation of that already available from a library. You remember we had always an include stdio.h whenever we wanted to say print, isn't it? If you wanted to print the results, we'll say printf. Printf is a function. In order to invoke printf, we included standard io.h library, which defines the printf function. Similarly, we now want the power function. So the power function is defined in a library called math.h, okay? Math.h. And it takes a base and an exponent, and it returns a value. Remember, usually every function returns a value. It returns the value, the result. So the result of base raised to the power of exponent gives a return value result, which we want to store in the result. Whatever results we get, we want to print. We know the printf takes a string literal, isn't it? Printf is a function that takes a string literal. We want to say print those to the power of f is equal to %f \n, and then say base to the power of the exponent will give result, and we want to print all these and see. So what is left here? We have used result, base, exponent. Yes, we are dealing with real numbers, isn't it? So they are also called floating, we have defined, and power is a function that is defined in math.h, and printf, which we are aware, is from stdio.h, where it is declared, okay? With this, our program is complete. Let's compile and see, okay? If you try to compile this, you see two errors. One is a warning which we know about, where it says return type defaults to int. We said every function has to have a return value. We didn't give a return value to main. It implicitly took int. In order to get rid of the warning, we probably should, as a good programming habit, go and declare this as int main. And if you don't return any value, a value of 0 is assumed and returned by default. But let's be explicit, again, as a good programming habit, and say return 0. 0, usually a return value indicates that it is success. In this case, it's success. With this, if we compile now, if we say cc power.c, so that warning is gone, but we'll have still an undefined reference to POW, the power function. This is because the power function is implemented in a library. Just like printf is also implemented in a library, the power also is implemented in a library called a math library. But then we didn't get this error when we used printf, isn't it? That's because printf is a standard IO library and it is automatically included in C when you compile. Whereas the math library is not automatically included. We have to explicitly include them. So the way you do that is say cc power.c -l. L is to say link, m is to say math library. So include math library in which power function is defined, and we have used it, and therefore this completes the compilation. If you do this, it should work, and then you run this, you expect a value of 8. You see here 2 raised to the power of 3 gives 8. So we have used a function called power. We don't know how it's implemented. It could be simple, it could be very complex, but we know that we want such a capability. We know what to do. We don't worry about how it's implemented. That is how you construct programs. Okay, you define a function and then you invoke functions and you keep doing that till you can solve your entire problem. Okay, in this program where we just printed a base raised to the power of an exponent, calling the function power, right? Here, if you look at the variables we used, result, base, exponent, these are all real numbers. So we have declared them as floating point numbers. So this float says that it is the type of data that we want. What is the kind of the values that it should have? So those are called data types. And if you see in this program, line 8 was executed, following which line 9 was executed. How did it know that after 8 the control should pass to line 9? It's because of this statement. Here you see this symbol, semicolon. Semicolon is called sequencer, line separator. It's a program sequencing instructions. So this is control flow. A basic control flow is to say that execute anything before the semicolon first and execute everything after the semicolon next. And in fact, this semicolon that tells that line 9 has to be executed after line 8, following which line 11 and so on. So this is a control flow. So today we'll delve a little deep into data types like float and control flow like the semicolon sequencing instructions, right? There are a lot more. That's where the power of C comes and the richness of C comes, and we will cover that in detail today. Okay, all right. So if you look at the basic building blocks of C, we declared variables, and variables announce the property through declarations. If you look at this diagram here, we say int n comma I. We declare and announce that n and I are integer types, and n and I are names which can hold values, isn't it? It's the name of the variable. N is a name, I is a name. C is rich in data types, and I have made an exhaustive list. You can look through this. We used float already, and it has characters, integers, floating point that we used, an array of those. Look at these Roman numbers I've printed here. We've said M, D, C, which are all familiar Roman digits, isn't it? So we have made a list of that. List is called an array in C. We can have a structure. For instance, you want to gather IO statistics, then you would want what are the amount of reads and what are the amount of writes issued, and then you would structure them and then say that I would want to count the reads and then count the writes separately, isn't it? So you can use structures. They're called structures, and there are unions and pointers which are more complex types, which we'll cover in detail when we go into the detailed modules. But these are the set of rich data types available. Next, the sequencing. We know that the character semicolon placed between program statements denotes the sequencing of the statements. We saw that, right? There are a few control flow statements in C, which is found in every language, but these are the most basic ones I'm presenting here. And if then else says that if a condition is met, you have to execute a set of statements. And if the condition is false, then you can go and execute in an else part. A switch statement, which gives you an option of going to multiple choices. For instance, if you have a multiple choice question, you will say A, B, C, D, and E. So you say A is an option, B is an option, C is an option, right? So similarly in a program, how to go to option A, how to go to option B. That's a switch statement. And many times you want to repeatedly do things. See, in computer programs, the power comes from doing something repeatedly. So there are basic loop statements, while and for. These are best learned by hands-on. So I would rather go into the details with the hands-on. The most important thing you need to remember is these data types we talked about earlier in the previous slide and the control flow here together. These two together is what makes a program. So a data structures plus control flow is equal to programs. Okay. So let's go and do some hands-on in order to understand all these things. For that, let us write a simple program. Let's call it compound interest, right? Everyone knows compound interest. I'll call it cinterest.c. As usual, there's a main program, correct? And then usually we are using printfs. So we say include stdio.h, and we want to include power function that we had from last time. So we want to include math.h. Next, we want to compute compound interest, isn't it? Compound interest. What is the formula for compound interest? Amount is equal to principal into 1 plus r by 100 whole to the power of n, isn't it? If you remember from your high school days, this was the formula for compound interest. So let's do this actually. So what should we do? Ideally, we just want amount is equal to principal into, we want to use our power function, isn't it? Power function into 1 plus rate by 100 comma I, isn't it? That's how we define the power function. So this is principal into 1 plus r by 100 whole to the power of n. Of course, we have to declare these variables. We use data types. What are the data types? We say amount, principal, rate. All these are real numbers, floating point, right? So amount, principal, and rate. And the duration, you always want to say n years, isn't it? So you would say int, because it's 1, 2, 3 years and so on. So we declare it as int n. We are going to use some temporary variable. We'll name them here also. Or you don't want any temporary variables. We just stick to what we know directly from the formula, right? So we have our basic program ready. Of course, we want to give some values, right? So we would like to say principal is equal to, let's say 1,000 rupees. You want rate, let's say 15%. You want the duration, number of years for which the compound interest has to be calculated. Let's say it is 2 years. And we have the formula for this. As we said from the last time, a good practice is to have a function return a value. So we say int, and then if everything goes well, we want to return 0, isn't it? Of course, we want to print what we have calculated. So we say printf, we say for period is equal to percentage d, d stands for decimal. We want to say amount is equal to percentage point to lf. F stands for, LF stands for long float. 0.2 says up to 2 decimal places we want to print. Okay, I comma amount, not I, it is n here, isn't it? N is a variable. And then what was the principal? We'll print that also. Printf principal is equal to percentage f backslash n comma principal. So this completes our program. This is the sequencing, saying that one line after the other. This is the data types, float and int. So we are calculating compound interest using a standard formula. We've used the function power, which we encountered earlier, and our familiar printf to print values wherever we want. All right, let's run this program now. So we say cc cinterest.c -lm, isn't it? It compiled. Let's run that. Here.out. So if you have a principal of 1,000 rupees, and if you were to keep it in the bank via compound interest for 2 years, the resulting amount after 2 years is 1,332 rupees 50 paise. Okay, so this was a basic program. Now you would like to know, well, this is okay, but I want to know if I'd kept the same amount for 3 years, what would have been the case? If I'd kept for 4 years, what is the case? What if it was 5 years? So you want all these what ifs because you want to decide how long should you take to deposit and get the amount you want, right? So to do that, let's copy this program and then call it cinterest loop, because we want to calculate in a loop and say, how do we go ahead and calculate for multiple years? This is where control flow comes in. So this was for a flat 2-year. We want to calculate for 2 years, 3 years, 4 years, 5 years, and so on, right? So we could do this in a loop. What would we do? We would say, after the principal, you want to say a while it is less than 5 years. I want to calculate for every year, how was the compound interest growing? So I would say n, and in order to calculate for every year, we would like to use a temporary variable. Okay. What would you do here? You would then say, while you start from year 1, I is 1, and then you would say, while I is less than n, because while is not yet 5 years, what do I want to do? I want to execute these, line 19 and line 20, these two, right? I want to execute these in a loop, correct? And we indent this just for making it look pretty. This indentation is not required. It's nothing to do with correctness. It's just for better readability and maintainability of a program. So we say this is a condition. You see here, while is a loop variant. It says the following statements, line 19 and line 20, are to be executed in a loop till this condition becomes false. This is a condition. So while condition is true, execute whatever is in the loop. While condition becomes false, then you come out of the loop. Okay. So while I is less than n, it means first time through the loop, I is 1. And then you calculate for 1 year now and print that. Okay. And then you want to say I is assigned to I plus 1, because you want to now say what is it for 2 years, then what is it for 3 years. So basically you've taken the old program, we just calculated only for 2 years and modified it to say I want and what if. I want to know for I is for 1 year, 2 year, 5 years, it could be 100 years. So it gives you the power of being able to continuously find out for a range of values you want, isn't it? Let's see how this runs now. Okay, we basically use the same old program but did things in a loop now, and for that we used a variable we want to count. This is the loop count variable. This is the limit up to which we need to count. We start from 1 and up to n. It's not less than n, it has to be less than or equal to, because we want from 1 to 5 years, isn't it? So these kind of operators, less than or equal to, these are called operators. That's all in C. Arithmetic operators, logical operators, we'll cover all these in future. This multiplication is an operator, this addition is an operator. All these are operators which we're all aware of, isn't it? So let's run this program where we have introduced a loop statement. So let's the same, let's go and compile this. We compiled it. Now let me run this. That was the old program. Now we called our new program as loop.c. Let's compile this. Now when we run this, we should get for multiple. You see now here, for period of 2 years, it's the same thing, no doubt. But now we are getting values for all the years, for 1 year, 2 years, 3 years, 4 years, 5 years. So effectively in 5 years, your money of 1,000 rupees gets doubled, isn't it? So you could, this is the power of programming with loops, isn't it? Now, another variant, we used a while loop. Maybe we can try something else. We can say copy loop to loop1.c. What do we want to do here? There is another loop variable called for. So you see here, I was initialized here, we checked here, and we incremented here, isn't it? Instead, we could have said for I is assigned to 1, I is less than or equal to n, and then move this statement, I isn't I plus 1 here. We just literally say that I is assigned to I plus 1. If you do this, then you can get rid of this and get rid of this. Is it any different from the previous program? No, it is not different. It's the same, but it's more compact. So whenever you have a beginning value, a condition to check, and at the end you increment that value, it's a natural fit to use a for loop. So this is called a for loop in C. Let's execute the same thing. We made no change other than just restructuring this to use a for loop. Let's compile this. We're going to compile this now. So it is C interest loop1.c, isn't it? It's the same thing, but using a for loop. And we want to execute this. It's identical, isn't it, compared to the previous results. So these are the two loop constructs, while and for, that are repeatedly used. All right, so this was a brief overview of data types and also the various control flow. All right. We encountered control flow statements like the for and the while, isn't it? But more often than not, we all are familiar with the constructs such as if this condition, do something, else do something. We use this even in our daily life, isn't it? So let's see how we can use such constructs within C programs. So let's revisit our previous program, compound interest.c. Let's say before returning, we want to also say if the amount that we got is less than 2 times that of principal, then we want to say if it's less than 2 times that of principal, then we want to say goal of doubling principal not reached. Else here would mean the condition is false. That is, amount is not less than, which means it is either greater than or equal to 2 times. If that is the case, then our goal is reached, isn't it? So goal of, I would say, reached. I'll say congrats. All right. So what have we done here? We have introduced the if and the else control flow. What this does is, if a condition, this is a condition, execute something. So if the condition is true, execute this. If the condition is false, then you go to the else and execute the statements below else for the condition being false. So as you can see, after an if, we just can go ahead and put all the statements. If you have multiple statements that you want to execute, then you'll have to use these braces in order to indicate that everything after the if till the else should be executed if the condition is true. Else, if you have, to make it real, let me write this. Let's say printf inside if. Else, we want to say inside else. You see what we're doing? We're executing multiple statements. So when you want to have multiple statements, then you have to delimit them with flower braces. This says all the statements. If I set the line numbers, line numbers 25 and 26 are if the condition is false. Line 21 and 22 are if the condition is true. This is called the conditional statement. Let's execute this. Okay. So let's execute after compiling, of course. So we know that we have introduced power functions. So we have to compile with math library. Did that. You see, goal of doubling principal is not reached. Why? Because your amount 1322.50 is way less than twice the principal. Twice the principal is 2000, right? So let's try to do the same thing in our loop. So the same condition we want to put. So I'll copy this into the next program and just do the same thing. This is the C interest loop, the same conditional statement, and try to execute it. So we say cc-lm. Okay, execute this and see. You have reached your goal. You are inside the else, isn't it? Why? Because after 5 years, when compound interest was calculated, you were beyond doubling your principal, and therefore this is else. You see how you can sequence the flow of program by using if and else. If and else is very powerful to be able to give you the flexibility to detect a condition and go ahead and do certain actions and detect if the condition is false and thereby go and execute the set of statements and actions. Okay. Another few things that may be worth knowing. If you look into the program we just executed, interest loop.c, right, that we executed, you see here we have this while loop. We have I equals I plus 1. So this is I is assigned the value after incrementing I by 1, isn't it? There are shorthand notations. There are more operator supported in C. And so you could instead use operators like I plus plus. This is just a convenient notation. It is the same as I is I plus 1. It's just a shorthand notation, nothing else. Okay. Let's see if it executes the same. What are all these? These are all operators. Less than is an operator. Less than or equal to is an operator. This is an assignment operator. It says to the variable I, assign a value of 1. And in this case, it's called the increment operator. You see, it's I plus plus, it's an increment operator. What is its effect? It's the same as I is assigned the value of I after incrementing it by 1. The shorthand notation is I plus plus. It's very convenient to do this because many a times we increment counters and it just shortens the program, makes it easier to read and write. It is the same as this, no difference. It's just a shorthand notation. Okay, this is called the increment operator. These are all operators. Let's execute this after compiling it. Should be no different. It's just a different operator. It's a shorthand notation. And let's see what it says when we execute it. Identical, right, to the previous one. If you see here, previous execution where I assigned I plus 1, and in this case where we said I plus plus, the increment operator. These are the operators. Okay, so rounding it up, we said in C we have control flow statements. The sequencing, it says go to the next statement. The if then else, which we saw, there's a switch statement which allows you to go to different options, just like in multiple choice questions, right? You have A, B, C, D, and E. If based on the value, you want to look at a variable, look at its value, and then say, oh, if the value is A, go to branch A. If it is B, go to branch B, and so on. It's sophisticated form of the if then else, that's all. Today we covered the if condition, then execute a set of statements. Else, which means if the condition is false, execute a set of statements. While and for, we're familiar with, and we've already covered those. Okay, we covered operators too. This is an addition operator, we've done that. Subtract operator, multiply we have used. This is divide, this is modulo operator. There's all the arithmetic operators. Relational and logical operators, we use them too, right? If it's less than or equal to, we use this in loop constructs, saying that if I is less than or equal to 5, or we also used saying that if principal is, if the amount is less than 2 times principal, and so on. These are increment operators. Similar to increment, you can decrement. That's called a decrement operator. This plus plus is no different from adding 1 to the variable, isn't it? So similarly, decrement is nothing but subtracting 1 from the variable. These are the bitwise operators. Bit operations are very, very handy and useful, and C is very, very efficient in that. We will not go into the details of covering bitwise operators here because there is a separate module on operators. We'll go into that. But these are bit operators which say, is this bit set? In a variable having 32 bits, is the 5th bit set? Can I AND 2 set of variables on their 5th bit? So on. Sophisticated things. You can negate all the bits. You can exclusive OR certain bits. You can OR them. You can AND the bits. You can left shift the bits. You can right shift. What is left shift? Left shift is multiplication, isn't it? 2 left shift by 1s is nothing but 2 into 2. 2 left shifts by 2 is 2 into 2 into 2. So on. Similarly, right shift is division. All these are again self-explanatory. Some are, this is comparing equality. Is some value equal to some other value? Is A equal to 10? Not equal to, is it not equal to 10, for instance? And these are logical operators. We say if this condition and another condition. So you notice here there's a double AND to distinguish from a single AND, which is a bitwise operator. This is a logical operator. This is a bitwise operator. Similarly, an OR is a logical OR. This is a bitwise OR. This is a logical NOT operator. This is a bitwise negation or NOT operator. So this control at both levels. So that brings us to the end of this session. Thank you.